Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and today we're going to look at running the larger 4-pole dual pole motor off of just one MOSFET. In fact, this is the same little MOSFET that we were running on the 4-pole mini kit until I upgraded that to this MOSFET, which is a lot faster. So this is the old MOSFET, and I'm going to show it running one wire strand per coil out of the 8 at 12 and 24 volts here. So first we're going to look at 12 volts, and we're just going to run it on a low battery discharge battery because I don't want to push this MOSFET too hard. We're actually going to use bigger MOSFETs in the end on a heat sink and even water cooling it so we can really push a lot of power. So this motor is capable of about 1,000 watts per coil, or sorry, yeah, 1,000 watts per coil. So roughly 20 amps at whatever voltage you want to run at. After 20 amps, you'll probably get too much heating in the coil there, especially when I have these shrink tubes around them. They hold the heat in. And after that, you can probably go up to 25 amps if you make sure you don't have that in there, and maybe put a little bit of a fan on the shaft internally. Circulate some air in there, keep it cool. But anyway, power wise, we could run this at whatever voltage we want, as long as the rotors can stay on the shaft. In that case, right now I just have 2 set screws on each hub here, and what we'd want to do is put some flats on there so that we could really crank some torque off of this thing. So anyway, these FETs right here are 2,500 watt FETs that I've been using for the last couple of years. And so what we'll be doing is driving this, of course, with bigger batteries, and we'll probably do 1 FET per 2 coils and just have 2 FETs for this particular model. And that way we could crank this thing up to 4,000 watts at 50 volts. And that would be the maximum I would really want to push, because when you have startup under load, you're going to have definitely a lot more amps. So I would recommend not starting this up at full amperage under load if you're going to do that. Anyway, I'll show this later on in another video running with the whole water cooled system. So right now I've just got this little piddly 300 watt MOSFET on here, and this is a slower switching one, and like I said, this one is a little bit higher amperage and voltage. This is a 100 volt MOSFET that we use on the little 4-pole mini kit now, and it's much faster switching. It's half the resistance of this one. So it's a major upgrade. But anyway, we're just going to run this one. You'll see the spike is lower than this one would produce because the on and off switching is slower. And this is why initially, without the gate driver, the spike isn't very high. So you're not getting as much charging and what we call the negative energy phenomena. So what we want to do is charge up this battery. Oh, I see. Anyway, this battery here, what we're going to do before I get this all started, I want my batteries to stabilize a bit because I was running this for a while. So this is at 1204 volts. And so what we're going to do is run 3 of the generator coils off of 3 of these generator coils we're going to run into this battery and charge this battery with what we call a capacitor pulsar system. So what I have here is just the AC wires. So I've got these wires coming out here. Somehow going down to here. And what I'm doing is I'm bypassing this bridge right here. This bridge is just to have a DC output, and what I was running the LEDs off of, which I'll do in a moment with these here. We'll see which ones are good, which ones are bad. These ones right here are all bad. They're the cheap fake, or the bad ones that you get mostly from eBay. Most of the ones that you buy from eBay from China are bad. You have to find a good one, which this is a good one we'll see here. So we're going to run this 4th coil off of these 2 wires here, and for now we're going to short them out because well, actually we don't have to short them out right now, but when we start it up in 24 volts I have to short it out, because remember, when I short it out, it speeds up. When I short out the generator coils, the motor speeds up. So what we're going to do is start it up. I don't have to start it up under, I don't have to do that under charge, or under 12 volts. So what I'll do is I'll run this to start. So you'll see this under load. And then when we go to 24 volts, remind me to short that if you were here. Alright, so what we'll do, we're all plugged in here, is get the amp meter going here too. I'm not sure the best location so that this can be seen. Let me take a look and see if that is viewable. Yeah, it should be viewable. So this is the charging battery. I've got them kind of reversed. And this is the input battery. And then, so this is the charging battery back here, and this is the input, and then this will be the second input. And I'm not going to put 12 volts or 24 volts charging. I don't need to, I'm not trying to prove something here, I'm just trying to demonstrate some basic details here. I guess I'm making way too many videos these days, but whatever. Alright, so now again, this is pretty much self-starting. I just have to put it in position, and once I put this on and off switch on there, then, and then I move it position, it will start up. So I'm going to look at my, so it's going to start up with pushing about 20 amps. So it's about 22 amps at startup. So there's another good LED. This one's a good LED. So, so it's going to level out about just under 5 amps here. So now I'm running all 3 of those LEDs in series here. So this one's getting hot, or at least fairly warm. Again, I'm not going to try and prove too much with these lights, but I will turn off the other lights and take a look. So that is pretty bright. So this battery is 1229, this input battery under load, and then this one's charging up 1191. You can see the spike on there. So we look at the amperage now. First of all, I want to look at the temperature. So the temperature is only at 84 degrees. And that's Fahrenheit, 85 degrees. And so we're at 5 or 6 amps. And that's under load. Once I get it up to speed, it will drop back down the amperage. So what did I say? 1129 times 6 amps. So we're at 67 watts right now. And we're definitely running these LEDs at that power level. They are very bright. Of course, if I turn this around, see, oops. Now you got your little workspace light. So that's that one. This one. If I separated each generator coil out by itself, I would have a whole lot more light. Oops. So this is getting warm. Pretty bright. Anyway, that's not my point of showing this. Now that's a 200 watt light lighting up the room. Now anyway, what we're going to do is look at all these things. So we're at 86 temperature, we're good there. And then what we want to do now is start charging this battery. Well, first of all, let's show it shorted. and it's sped up quite a bit. Now let's turn off the power first so that we can see the other three. So now it's going to spin a little faster. 5.5 amps. So now I'm going to short it out. You can hear it speed up faster. So this battery's at 1204 volts. What we're going to do now is start charging this battery. See, it's 479 when it's all shorted out. So it's speeding up faster, charging the battery still. So now what I'm going to do is charge this battery. Now this is a 300 volt photo flash capacitor here with the SCR pulsar. So you notice, because the load actually 495. If you match the load just right, it won't discharge. As this battery becomes more or less charged, that will change. So we're already at 1206 volts here, and this is going to be a slower voltage charge. Like, this is not a higher over voltage scenario here with this battery, with this pulsar. This is going to keep it a couple of volts. I think it's 3 volts, so it's 1206 DC. And if we look at pulses, it's 1286. So it's pulsing that not even about, or just about half a volt higher than its input. And on the AC side, it's a little bit higher yet. So we're at 1207. So that's charging. Again, this is not with the preferred MOSFET, but it is with the new gate driver circuit in there. So you can see we still have about 200 volt spikes there, but with the other MOSFET we'll have higher, especially with these big hyper fast and MOSFETs, these really big ones. So I'm going to go up to 24 volts now, and what we're going to do is short everything out. Now that one's still shorted. And then let's look at these voltages here. So I wanted to keep these batteries discharged so that I wasn't going to push too many amps here. So now what I'm going to do is, my on and off switch here is going to the primary positive, but I only want to keep the circuit at 12 volts. So I'm going to move this over there, as well as move this to the 24 volt position. So I'm going to just disconnect this for a moment, and then we're going to go up. So let's get this all lined up again. This is just kind of hanging by a thread here. And actually I don't want it to go too slow, because I want it to not draw too many amps. So you can see we're at 9 amps and descending. It's going to go down to about 4 amps here once it gets up to speed. So again, this is no load situation, and so we're at 6.9 amps. Of course, this battery is still at 12 volts, so it's going to charge fast. And of course, these ones I got to change my voltage over. So it's at 22.8, and these are very bright lights now. Now it's lighting up. I can't even see anymore. So we can see, of course. Start charging up this battery again. This battery, 12.6. Now I'll disconnect that. That'll charge up this. So you gotta match the load on these generator coils. So now 12.6 going to 12.7 and so forth. So the MOSFET, all I want to do in this video is show the MOSFET running. It's 92 Fahrenheit. And I've got a 10 amp diode in there only. So this is running at 7 amps or so, depending on where you place it. So anyway, this could be a battery charger, these generator coils. You can charge up a capacitor and use it for whatever purpose. As we're doing here, we're charging up the cap and then dumping it, the SCR, into the battery. So now we could do other things as well. You can actually power any load while you charge a capacitor. But this is not a resistive output. It's a different type of output. So let's check out a couple of these LEDs right now to see which ones are good. So I want to explain some of the differences. Ow! Yeah, I knew that was going to happen eventually. That's really high voltage. So that's a good, definitely a good LED. You've got to watch where you place the connections though, because they're kind of backwards. So there's a blown one. No good. And it's kind of hard to say which one's positive, which one's negative. Here's a really good one. So I gotta go through all the ones that I've got. And there's another good one. So that's fairly bright. So when we get the higher switching, I'm going to go back to charging my battery here. When we get the higher switching, we'll get more output on the generator coils because the motor coils are affecting the generator coils as well. So we're going to charge up this battery. Now, a couple of things. Might as well turn this off. Let's just see. All right, so actually, it's better to run the generator coils independently because they will actually produce more output individually than in series, I've found. And it really depends on the loads that you're running, of course. But you can see that when I was running all three of these in series, the light intensity was almost the same between them. So, and I've shown this a couple of years ago, running this with the transistor setup, where I had a whole bunch of these modules running. But ideally, they're better off running them individually into individual loads. But as you can see, I shocked myself pretty good there with this. It's pretty high voltage. Should have checked it, but once we get this thing really going up to the higher voltages, 48 volts and higher amperage, this thing will really fly. Remember, we're not using this. We're just running one coil per one wire per coil out of the 8. But again, we're not pushing this as hard as we want to. We could run, with this transistor, we could really run one of these FETs per wire what we were doing with the transistors. And so that would be, a lot of power there. Of course, what would happen is we parallel them up, the amperage would come down unless we loaded down the motor. And so that's the thing with the torque. These generator coils don't put lot of, they're more of a high RPM load. And we can still load it down and still use the generator coils as well. So if we get into the 48 volts, which what I'm going to do is set this all up in the near future when I have time and show this running with these transistors at 48 volts. I've got to get the battery banks all hooked up so that can be shown. And then we'll run these, you know, at the more maximum power. So 4,000 watts though at 48 volts is, well, just 4,000 watts is a lot of energy for this system. It's going to go extremely fast. I'm going to have to hook up an external generator to the shaft here. And I may show it running an air compressor. Well, this is what I do at my meetings. I show this running a big, huge fan. Last time I just put the blades right on the shaft and a big industrial fan. So I'll either show that in the video or running an air compressor, which I would like to do at my next convention. Now I will say this for those who are watching the video to this point, that I put this motor and the 10 coiler on sale at almost half the price less right now. So if you want to get these systems, I have a bunch of these in stock, and I've got 2 more of the 10 coilers right now. Otherwise you'll have to wait a couple of weeks once first come first serve. Get more inventory coming in. But anyway, I want to push this motor, and also what I want to do is put a vibration dampener on these plates. But under load, it's not an issue. There is no real load on this shaft. These generator coils are putting very little load on this motor. But if we have actually a mechanical load on the shaft, then you don't feel that. It's a lot slower RPM in that case, unless we're running it at full power at 48 volts. Now, the other thing that we can do is add the speed control on this as well. And that's, I haven't shown that with this motor, but I've done that. When I usually bring this motor to my conventions, I have the speed control on it with the water cooling and everything, and showing the big fan. Now sometimes I've hooked up the pulley to the big cage, and then like I said last time, I put it directly on there. So anyway, the speed control is great. It'll break up the pulse and width and allow you to adjust the power level. So that's easy enough to add into this system, especially with this new gate driver. And what else? So you can see the voltages have come back down, gone back up. 23.4. $11.92. So again, under load, which one was that? Trying to see. Oh yeah, so that's the charging battery. And then the input battery. It's going to come back to basically where it was. Oh, I have this here to remind myself. So if you look at these MOSFETs here, I've got high-speed, ultra-fast diodes on top of them. These are the ones I sell on my website. They're the 30 amps each leg, so 60 amps together. is what I want on those big FETs in order to really push out that power that we're looking to do. Here I'm just using the slower diode here, the 1000 volt, 10 amp one, as I mentioned. So that's going to be all included in the new kit. So if you order that kit now, I will include in probably about 2 weeks. I'll need to get that all organized, and like I said, on the new heatsink. So what I've done is I've reduced my costs, but I've upgraded the kit with a heatsink, and if I assemble it, I will include the water cooling. Otherwise, you're on your own to do your own water cooling. So in other words, you can run this just fine without the water cooling, but if you really want to push it really hard, then you're definitely going to want to cool off the MOSFETs. So again, if you run it at the lower voltage, it won't produce as much amperage, depending on the load that you're running it at, the RPM. So those are the details, and I think if we go into the 48 volts here with the higher amperage, what I'll probably do is make these generator coils available with 12 gauge wire, and that's what I'm looking to do to go up to the 250 kilowatt level. So with bigger spools and all that, that we're getting into the 12 gauge wire when we're really pushing the power here. So I think I'm going to make some generator coils on these spools even with the 12 gauge wire, and especially if we're going to run each one of these in series with each other and have those, the output, the voltage is going to be extremely high, so we have to really load down the system. So that's it for now. I think that covers what I wanted to cover, and what do I want to say, anything further? So yeah, I think next video we'll show this running in its final mode, and we'll go through 12, 24, 36, 48 volts and look at the power, and we'll run a generator. I've got about a 4,000 watt, well, I've got a couple of 4,000 watt generators that we could hook up either one of them to this, and so it can really load it down, because otherwise this thing would spin at incredible speeds, and I don't really care to do that. And then I think what I'll do is, by the time I ship out the next orders here on this, we'll have the vibration dampener. It's just a tape, very strong Teflon tape that we'll put over the whole plate, probably on either side. And that way it keeps the magnets in too. You know, if those were to come out, I mean, they're pressed in extremely tight, very difficult. I actually press them in for people before I ship these out, because I want them in there really tight, make sure that people can do that. They can't do that. Most people don't have a press. So there we have it. Like I said, the spike is bigger, as we saw with the little kit. With the little kit, the spike is quite a bit higher with the new MOSFET. So the switching time, I mean, this is a $5 MOSFET, that's a $3 one, so and that's an older one, so this is higher speed. So that's important, and of course these bigger ones will have the same kind of speed in them as well. I think that's it, so thanks for watching.